Hello and welcome. Today we're going to do something a little more technical, and that is we are going to create a plugin for HyperCard written as native code. And in the process, the plan is to kind of illustrate how color in HyperCard worked, or rather how HyperCard didn't have color, yet you could have color in your stacks. And so to do this, I've set up this emulator. So this is not a real Mac. You can tell by the 720p 16:9 screen, which wasn't really a thing back then. But, you know, the emulator is happy with that. And also, you can tell by this icon, which lets me access the PC's file system to get new files into this emulator. But anyway, so what do we have here? Let's take a short inventory first. So we have the hard disk with a standard System 9 install. And we've installed a few applications that you might not normally have. For one, we have ResEdit, which lets you edit resources on classic macOS. A file had a data fork, which is where, for example, the text in a text file would be, but it also had a resource fork, and a resource fork could contain like little bits of data. So the best way to show this is probably just to open a file. And since we're talking about HyperCard, let's grab our HyperCard folder, and let's grab HyperCard itself and open it with ResEdit. And now you see, this is all the stuff that is in HyperCard. Now, HyperCard is an application, so that means it actually contains the code that is run in the data fork. More importantly, the PowerPC code, since this emulator emulates a PowerPC Macintosh. However, HyperCard also ran on 68,000 Macintoshes, which were the first Macintoshes before Apple switched to PowerPC CPUs. And so the code for 68,000 is actually kept in a code resource. So originally, Macintosh applications had nothing in the data fork, and a code resource, or rather a lot of code resources, that implemented all the different parts. You see they've actually here been nicely named. So you see like the compact stack command is like a separate resource. The painting tools are a separate resource. The dialogues that it uses are apparently there. The printing code is separate. The icon editor is separate. Indenting scripts is separate. The advantage of this was that it could just load one of these parts as it was needed and unload it to free up RAM later on. Yeah, that's basically how it works. You can also see like all sorts of windows. So dialog windows, so every resource has a type, which is a 4-character code. So for example, CODE, all uppercase, is code for 68,000. Curs is a cursor. So you see here the hand cursor that you use that you see everywhere in HyperCard is just a resource here. And the little arrow cursors that you can use to move the divider in the message watcher, in the variable watcher, is here. And the little check mark that your cursor turns into when you can set a breakpoint, things like that. Also typefaces, fonts are kept here. So HyperCard actually came with a font. So font is actually the font definition, I think, or font description. And there was font with a T, or NFNT, which is a new font, is the newer style of fonts. And so what do these fonts do? So you see they had different icons that they showed in the menu bar. For example, this lock icon that in a write-protected in a write-protected stack showed. What else do we have? We have another copy of the hand cursor. Right, this is the icon of the browse tool, not the cursor. The button tool, so like all these icons in the tool palette, for instance, are in this font. You see also the filled variant versus the unfilled and things like that. So someone decided that that would be a good way to store all these icons, is by storing them in a font. The debugger icon that is used for the debugger menu is in here. Things like that. I don't know why they actually used a typeface for that. Maybe it was somehow easier to just create a menu in the menu bar and make it draw its title in a different font. I don't know. And also you can have images, which are pictures. You can see the Navigator Palette here that you can open in HyperCard. You can see the little arrows that are shown next to the text fields in the print report for the dimensions, things like that. There's also the About screen in here as a picture. So all of that stuff is in here. So stuff like that can be put into the resource fork. And one important thing that you see here is XCMD, external command. And so HyperCard had plugins that were written as native code and that could be called just like a handler. So if you look here at XCMD, for example, the flash command is just an external command. The script editor, variable watcher, and message watcher are actually also implemented as these external commands. The reason for this was that allowed someone else to create their own script editor, variable watcher, or message watcher with more features and replace it. The palette command that, for example, can be used to show the Navigator Palette is also an external command. And the picture and movie commands are actually also native code plugins that were just integrated into HyperCard itself, instead of implementing them as actual HyperCard built-in commands. I think this was mostly just done at the end. These commands, especially movie. So I think picture and flash were probably just added to as examples. And I think movie was basically like at the end where they didn't want to change anything about the HyperCard file format, so they said we just make it a native code plugin that's completely separate from HyperCard itself, and you just write text into your script that triggers this command, which means if an older version opens this, it will only show an error message saying, I don't know what this movie command is. Or rather, what it could also do is just, you can copy this command into your stack, and if it gets opened with an older version of HyperCard, it will still use this external command. So now, why are there two copies? Like Flash, Picture, and Palette are there as lowercase XCMDs as well, and as uppercase. What's the difference there? Well, the reason for this is that originally HyperCard was written for 68,000 computers, so an XCMD, all uppercase, was 68,000 machine code and couldn't be run without emulation on a PowerPC Mac like this emulated Mac here. And so if you wanted to provide a native version, one of the things that you could do is just put the native code in a resource of lowercase XCMD, and when in HyperCard you triggered a command that it didn't know, and it checked first, is there lowercase XCMD, then run that. Is there an uppercase XCMD with that name, then run that. So that's basically what's in there. You can also see all the HyperCard menus in there, where you see that some are double. That's because, for example, this is the menu for normal browse tool, and this is the menu, you see import paint, export paint. So this is the file menu for when you're using one of the paint tools. And then also here is a shorter version of the file menu, which is the file menu that you get at the lower user levels. So if you locked out some of the features in your HyperCard stack, all of that stuff can be found in here. And there are also localizable strings. So, for example, here, you can see, well, the messages are actually kept as strings as well. But, for example, let's see. Here, for example, help text. You can evaluate any HyperTalk expression, FatBits window. I think these are the balloon help text that was shown when you pointed at an item on the screen. Things like that. So like all the text that needs to be translated is in here, for instance. So that's what resources were usually for. I mentioned the dialogues and then didn't show them. So for example, let's see. I think we had button info. Yeah, here. That's probably a one that you'll recognize. So, oops, clicked the wrong one. Button info. So you see here, it roughly looks like the button info panel. So it has the button name text field. It has these description fields with placeholders that get replaced with the actual numbers. It has a custom control here that implements the pop-up button. So those are here. It has these checkboxes and text fields on all the buttons that you see, and it has a box in which it will draw the preview. So all of that stuff you can check out with ResEdit in such a HyperCard, in any file on the Mac. And so what we're going to do is we're going to create an XCMD today. And to be able to do that, we need a few things. For one, we need a development environment. The one that we're using is called CodeWarrior, and that was kind of the most popular. It was a commercial software that you bought, and it's just a program with which you write code in C++ or C, and then it will actually compile that into applications or code resources. So you could write your own HyperCard using CodeWarrior. What we also need is some documentation. Remember, all that stuff, you cannot find that on the internet. It's all just, that was the early days of the internet, and since nobody's used them for a long time, there isn't much left of information about HyperCard out there. You'd probably end up on hypercard.org if you search for anything. So that wouldn't be helpful. So what do I need? Well, there was this book series called Inside Macintosh. And these files are kind of like PDFs, but they aren't PDFs. They are in a format called DocViewer. And you could just buy a CD-ROM containing all these files, and these are just books describing how to use the commands that Apple gives you for creating applications. So we'll be using that. Also, CodeWarrior itself came with a little bit of documentation. Let's go back in here. So it has CodeWarrior documentation in a folder here. There is a lot of stuff in here that you could read if you install CodeWarrior. one important thing is target Mac OS. And that basically describes some of the special things that you need to do. And these are actually PDFs. What you are especially interested in is creating code resource projects. So that's what we are going to do to create an external command in HyperCard. And that describes all you can do. We will create a PowerPC native code resource. We could also create a 68,000 CPU code resource or a FAT code resource, which is what Apple today calls universal binaries, which is basically one code resource with uppercase XCMD in the name that starts with a with a 68,000 code, and then after that has the PowerPC code. And the start of the 68,000 code basically contains a block that checks, is this PowerPC, is this running on a PowerPC in the built-in 68,000 emulator that your PowerPC has, that macOS had built in at the time. And if it is, it will switch back into PowerPC mode, jump out of the emulator. There was a special command for that. And jump to the end where the PowerPC code starts and run that instead. So that was a really clever trick that Apple did. All right. So much about all the opening talk. Now let's get going, I guess. And the first thing we'll do is we will start CodeWarrior. Let's see. I think CodeWarrior has already started, but yes. What I missed is it just starts into an empty menu bar. So I thought like, when is it starting? But it doesn't have a startup screen. So first we'll create a new project. Empty project in this case is what MetroWorks said. So like the documentation says do an empty project. What we will... No, I think we can actually risk this. The last time I tried it, I actually created a standard macOS Toolbox PowerPC project and then changed some things back. No, let's actually do that because that's what I did last time. But so the description will say create an empty project and add these things. But this should be easier for us. All right, so we go on into our hard disk, and we'll call this external command HyperColor. You will see in a moment why. Well, I already told you, because we will demo .mcp. Here, this is an important thing, by the way. Usually you don't have file name extensions on macOS. But the thing is, if we want to create a file named HyperColor and we name the project HyperColor, you will get a really confusing error message saying something about a file not being accessible or something. When you try to build, because by default your file, the output file into which your compiled stuff gets written, gets the name up to the file name suffix. And if, as a normal Mac user, you don't add a file name suffix, that means your project will already have the name, and it will try to overwrite your project, and then notice, no, this project is open, I cannot overwrite it. And will not overwrite it, luckily, but it will just give you a weird error message. So that's the first thing you want to do. You want to name it HyperColor.mcp. It will automatically create a folder named HyperColor around this. So we just say save. And now if we look at this in our projects folder, we have a HyperColor folder as promised with a HyperColor MCP and some example code. We also have this data folder which contains you know, like the data as we build it. So like the intermediate files that it creates and things like that. All right, so now we have created an application. So if we run this now, you will see we just get a window with these colorful dots. So that's a very simple example application, and that's the code that this silly balls example application here does. So that's really more than we want. We just want to plug in. So what do we do? Well, we go into our target settings, and here for the target, we switch from application to code resource. And the file name here, we actually set to HyperColor. So that's the name of the file into which we will write this. The clever thing that we can do is we can say merge to file. So usually it would create a resource file like you get for resEdit with creator resEdit and type resource file, and write the resource into that. But that's pretty pointless. What we really want is we want a HyperCard stack to test it in. So what we will do in a moment is we will create a HyperCard stack named HyperColor and put it in there. And since we check on merge to file, it will just add this resource when it builds it into the HyperCard stack, and it will be ready to use. Another thing I will do, because we want to register callbacks later, is we will mark this locked. Because on the Mac, memory can be relocated, can be moved around, and locked tells it that this external command shouldn't be moved around once it has been loaded. I'm also explicitly not marking it as purgeable. Usually, the ideal case for an external command is you mark it as purgeable and not as locked, and that way, when HyperCard closes your stack or needs memory for something, it can just unload your command and load it back in the next time it is needed. All right, and the resource type, of course, is XCMD. Make sure that is lowercase. Now, here's one thing. External commands are like commands. So you put them by their own on a line and say, HyperColor, I don't know, 15 or whatever, arguments the command takes. There's also XFCN, so like external function, which you can use to implement a function that is implemented in native code. So you could say, like put HyperColor opening bracket 15 closing bracket into my variable. So if your external command is more about retrieving data and working with whatever it gives you back, for example, if it downloads a file or whatever, then you would want to make it an external function. We also give it a arbitrary resource ID, not 0. Usually you should start at 128 or something like that, because everything lower is really reserved for the operating system. And since HyperCard has like 1, 2, 3, 4, 5 for the flash external command and things like that, you also don't want to be in that range with your number, so there is no collision. Usually lookup happens via the resource name, which we also set to HyperColor. So that's something that you want to do. Yeah, it must be relinked, that's fine. I want to turn on the C++ compiler. Yeah, let's turn on all the C++ stuff in case I decide to use C++. Enable bool support, definitely. And that's basically all that we want right now. Now here is one thing. You might think implicit arithmetic conversions, why isn't that warning on? The short answer is it would be really good to have this on, but Apple's own headers have code in them that has implicit arithmetic conversions, so we can't turn that on, sadly, because otherwise we'd get errors in system code. All right, and now the PPC Linker. Here is one important thing. Usually, a program has a runtime library with an entry point, which is called __start, and that does some setup work for your application, and then calls your main function. But here in this plugin, we actually don't need to do this setup work because HyperCard, as it has started up, has already done it. So it's very important to write main here so that it will call your main function. And also expand uninitialized data. That's from the Metroworks documentation. It tells you to turn this on. Was there anything else? I think that was it, yeah. All right, let's hope that that was all, otherwise I'll have to compare. And now we'll do the same for the, so you have a debugger and a final version. I'm not sure if the debugger even really works in this emulator. The last time I tried it, it didn't. So, but anyway, we still want to have the target. So let's do everything here again. HyperColor, both for the output file name and for the externals name. Oh, right, we forgot to set the creator. I'm just setting this to a HyperCard stack. Usually, I don't think it changes it, but just to be safe. XCMD 5000. And oh, by the way, it's important that we have this header type set to native. So that adds like a little preamble to our code resource so that it will actually run correctly. Again, all the C++ stuff and bool is what we want. And here, main. And expand uninitialized data. All right, save. All right. This resource file is where you can put resources that should be copied into the stack along with your code. So for example, if your code brings up a dialog window, you would of course want a DLOG resource and a DITL, a dialog item list resource, like we've seen them in HyperCard earlier. And that's where those would go. So what we'll be doing here is we should rename these. So HyperColor C, and here as well, HyperColor resource, of course, and also we can delete those too. All right. So now I've re-added the files that we renamed, and now we need to check for the libraries. So here is where it gets interesting. So we need a few libraries here. And for that, I'm now going to peek into my other project. All right, so I created this my flash external. And if we open this, so now let's look here. So what is here? So we have the MSLC and C++ library. What we also need is the console stubs, which is a file that MetroWorks provides. So if you reveal that, you see it's in MetroWorks CodeWarrior standard library MSLC Mac source. That just makes things like printf do nothing because we don't really need them in this, and the Mac doesn't have a console, so there's no way for them to go. The MSLSU PPC lib is what would do this in an application. But the problem with that is that, you know, assumes that it is in an application and opens a window that might royally confuse HyperCard in which it prints its text without HyperCard knowing about the window. So we need to remove this. We also instead need the so that's what we need the console stubs for. We also need a runtime library. Now again, the MSL runtime PPC lib is actually for applications, and what we need is the MSL drop-in runtime lib. And then the last thing we need. And so how did I find out about these? Well, part of it was remembering that there was something like that. So knowing what I just told you, that the Mac doesn't have a console, and that this SIOUX, standard input output user exchange or something like that, extension, something like that, that comes with CodeWarrior, that simulates that by creating a window and knowing that HyperCard doesn't like you opening random windows. And then I tried to build it and got some interesting error messages when trying to use, for example, snprintf, the standard C function, to, you know, convert a number to a string. And so what I then did is I went into Finder and did a search with Sherlock, and typed in some of the things that showed up in this error message. For example, I don't remember, it was something like write console and _UVF or something like that. So it was like some weird symbols, and I just searched for them on the hard disk and checked if anything showed up in CodeWarrior, and found these files, and those made the most sense. So I'm not 100% sure that these are actually the files, that this is actually correct, but it seems to work for me. So if someone remembers from way back then how this is really done, feel free to drop me a message. And the last and most important thing that we need is the HyperX lib. That's also in a CodeWarrior folder, so we'll just grab this. And this is a library that implements everything about talking between your plugin and HyperCard, so that your plugin can tell HyperCard, you know, run this command for me, or send this message to the current card, or something like that. And so you also need that one. So now we have all the libraries that this has. So there's one more thing. If you try to create this program. So first, most important thing, the main function in a HyperCard stack looks like the following. So pascal void main. So the Pascal is important because the Mac was originally designed in Pascal. HyperCard was originally written in Pascal. So the calling convention, how a function is called, is different between Pascal and C. And so with this special extension, the Pascal keyword Apple let you declare a function with the Pascal calling convention in a C program, and we're using C. And now we include, I'll copy that so I don't mistype it, the HyperCard XCMD.h header. So that's the header that goes with the HyperXlib that we used here. And that defines this XCMD pointer. And if you look at this XCMD pointer, by the way, this is a nice trick. You can select something and just say find and open. Command D is what I'll be pressing, and quickly jump to the header. You see there's a lot of stuff defined in here, lots of constants and things like that. And here is the XCMD block, and this is a data structure that your command gets given that contains an entry point, so that's a function pointer. And basically you call this function to call back into HyperCard. You don't do that manually, though. This library actually contains a lot of functions that take a XCMD pointer as their first argument, and these set up the XCMD pointer, then call the entry point, and extract the return values that HyperCard gives you back out. So this is, you can just call these functions and forget that this XCMD pointer exists, except for one thing, and that is that this XCMD block also has parameters. And these are the parameters, and this param count are the values that are given to your external command by whoever calls you. So in our earlier example of HyperColor 15, params.0 would contain a string containing the letters 1 and 5 as text, and then you would have to convert them into a number and do whatever you want with them. Alright, so far about that. So we have a command here, and for example, what we can do is we can call sendhcmessage. That takes a Pascal string, so we do \p to get that counter at the start of our C string. And then we can say, for example, answer hello from HyperColor. And so that's answer hello from HyperColor is just HyperTalk code like a scripter would do. So this external command wouldn't be really that useful. And sendhcmessage sends a message directly to HyperCard, not to the frontmost card or anything, just to HyperCard to let it run. There's also a sendCardMessage function, for example, with which you can send a message to the current card. You know, like if you wanted to simulate the sending of the open card message from something that your external command does. Or, you know, invent your own message, because your external command, for example, opens a web server, and then when someone tries to contact the web server, you would send a message to HyperCard saying, you know, I received this message. Anyway, so this should be totally fine. Now, one more thing we need. Oh, right. No, let's cause the error message. But let's go in here first. I have a test stack here already, so I'll just copy that over and call it HyperColor. And so now when we build, we should install into this stack. So let's build. And it says undefined proc info data. So this took me a while to figure out, and again, I, in the end, did a Sherlock search and searched for proc info. And it found a folder of that name. I actually searched through the contents, but and so if you look in this folder, it wasn't quite obvious, but if you open this, it says you could use this product to determine the value for proc info. It is helpful for making fat resources, since fat code resource needs an appropriate value for the proc info type field. And then it here says enum UPP AE event handler proc info equals Pascal stack based. Result size is size code size of OS error, and stack routine parameter 1. So it defines like what this function returns and what arguments it takes. So here it takes two Apple event pointers and a long. And then it defines proc info type. Proc info equals this value. And so I went, okay, this makes sense. So I can just copy this code and adjust it for an external command. And that's what I did. So if you go into this MyFlash project where I already did this, you will see that here at the start we have a proc info. So let's copy that and paste it into HyperColor. What we will also need is the headers. So we will need to include the header mixed mode, which defines kpascal stack based and stack routine parameter and all that stuff. Now again, this is needed because on a PowerPC Mac there had to be compatibility with 68,000 Macs, and so they had to get this information somewhere so that if some 68,000 code tried to call into this native code, they would know how to translate the 68,000s calling the parameters into something that we here can understand. So we're just defining this here, and then we're happy. Let's be a little tidy. So I'm adding all these pragma mark things and these big comments, and the reason for that is that we have a pop-up menu here that shows you all the functions you've defined, and if you have a pragma mark, it also shows you that. And so we have the pragma mark headers here, so we can quickly jump there by just selecting it, like we can jump to the main function. And so as we accumulate more code in this file, it will get easier to find our way in here. Also, if you just do a minus sign, pragma mark minus, that gives us this separator line. So I have a clear separation between headers and this proc pointer and proc info and things like that, and the actual stuff that we will need. The actual functions, I mean. So just to help us navigate the source code a little bit. Modern development environments do a lot of this work for you and do use more colors to highlight different parts of your code, which makes it less important to have, for example, these separators, but otherwise I just wouldn't find my way around. All right, so now this should now hopefully build. It seems to, oh, but it's created a HyperColor RSRC, which is, no wait, that was, I think that was something it just created. Oh, wait. That file was totally correct. That was the Support resources, of course, not the file into which it built. Never mind, sorry. Okay, so now let's get resEdit and look at HyperColor at the stack XCMD. It contains an XCMD named HyperColor. Wonderful. So we got what we wanted. So just to be safe, I'll check. Yeah, we have it set to merge to files, so we should be good. Not that we accidentally replace if we create an icon or something. Okay, so now let us actually use this. So you see I've already prepared it, XCMD test stack, it has a button. And here what I will do is we will just call HyperColor. We'll also, this should not return any result. Like the result is the return value of this, which is usually an error message for a command. So we're not returning anything, so we should never get into this code, but I'm putting it in there for later so we can test that. Or rather leaving it in there for later. So let's push the button and hope that it doesn't blow up. Hello from HyperColor. You see it did essentially the same as if I typed in the message box answer hello. It's the same thing, but it did it through native code. So that's good feedback. So yeah. So now how do we actually work with all this stuff? So first we'll include what is it, studlib.h, or was it std.io? Something like that, because those are standard C headers, and since we've added console stubs and the drop-in runtime lib, we should be able to just use this stuff. So now, the first thing we want to do, of course, is we want to create an external command where we can say, oh right, I didn't show you that yet. So here's the thing. Let's create a new stack. Color test. All right. Now let's go to the home stack, and do we have color tools? Here it is. So you see this is in color, but it's also sort of black and white. Like this highlight is still black and white. So what's happening here? So we can install color tools in our home stack, and we will get this color menu. And if we now go recent cards, you'll actually see this card, none of the color shows up in here because recent cards comes from HyperCard and HyperCard doesn't see this color. So what is going on here? Well, if we go into our color test stack, we can create a new button here. That's fine. All right. And now we can do open coloring tools. Opening the color editor will install scripts and resources into your stack to allow it to display color objects. Okay. So what just happened? So now we'll quit this. And where did I create the color test though? I didn't pay attention. Color test here. We just created it at the top level of the hard disk. Okay. So it doesn't come to front. So open it with resEdit, and now you will see it's created a few things in our empty new stack. For one, it added an X command called add color and put some strings that this command does. It puts some picture that this uses, and whatever this is my copy bits. So all of this is what it put in here. So that means the color. So that's what this install did. And now let's start this again. And what we can do now is we can open these coloring tools. Oh, wait, let's go back. I think CodeWarrior might be eating our memory. But let's see.
Uh-oh.
Yeah. Okay. Okay.
Uh-oh.
Still doesn't work. Okay, maybe we have too much RAM? I don't know. So what you would usually be able to do here is do what you know, what HyperCard does. Sorry, I lost my train of thought there for a moment. Let's check out HyperCard, what memory is assigned to it, because you need to manually assign memory. Okay, let's set this to 4000 and try this again. Yeah, okay, now it works. So it was just the default assignment was too low. Okay. And so now I can click one of these buttons and give it a color. Click another one and give it a color, and I click this one and give it a color. Okay. And what you will notice now is if I move this button, the color doesn't come along. I first have to say redraw screen for the color to move. So you see what this basically does is it does it records where every button is and what color you've assigned it, and basically draws the color and then merges that into the white areas of your black and white display. And this is how HyperCard does color. So it's not really built in. And if you actually look into, is it the card script? No, it's the background script probably. No, is it the stack script? Come on, don't leave me hanging. Yeah, here it adds an open card handler that sends color me to this card, a closed card handler that locks the screen that just lets it do transition effects, basically, by keeping HyperCard from drawing the new card before it wants it to. And then color me says add color, color card, and the visual effect by default stamp, which is no effect, and no duration. And so that's all what this color me does. And basically what that does is it looks up which colors you've assigned to which buttons and draws the colors in the right locations, matching, you know, the shape of the button and things like that. It, you know, it knows the shape because it just looks at the style property. You know, it just asks HyperCard what is selected in this pop-up, basically. So that's, they've just hard-coded the colors for that. And in OpenStack, it does an add color install. On a closed stack, it does an add color remove. What do these do? Well, they allocate some space for drawing these colors in, and register with HyperCards so they get called whenever the window needs to be redrawn. And so that's what we basically will do now in a very simplified form in our HyperColor project. So how do we do this? So the first thing we do is we want to be able to make a difference between install and remove and color card. So how do we do this? Well, first we check if IO block param count is bigger, same 1. All right, so wait, if it's less than 1 is what we want to check, because we want to early exit. So now we have to, return, because we need at least the first argument to say install, remove, or what are we supposed to do. Basically, we're kind of building, several commands into one handler. That's why we need this. And so first we have to extract the first parameter from IO block parameters 0. Oh no, wait, not here. No, we do that afterwards. But what we need to do here is actually we need to give a result back. And so if you look in HyperXCMD, there is actually a separate handle return value that contains the characters for the return value. And so how do we do this? Well, we just allocate a new handle with the size of our error message. And that's, so let's say error message. So strlen is the standard, C way of measuring how long a C string is. And the interesting thing is, while in the other command we actually still used a Pascal string, HyperCard actually, for the parameters and the return values, uses C strings stored in handles. Because this can be a long amount of text. You might have like a full text field, 32 kilobytes of text as a single parameter, and Pascal strings are limited to 255 characters. So we make a handle that is exactly 1 byte longer than the length of the string, which means it includes the 0 byte at the end of the C string. Of course, we should probably declare that string is equals, and now we have to come up with an error message, which is expected operation name as first argument. If this was a real program, we would also mention like what the valid operations are. So let's do that actually. Operation name. Let's say install, remove, and fill rect is what we will offer as our commands. We'll do a simplified version of that, of course. All right, and so now we create a new handle, and then we use a command, pointer to existing handle, and that should be our message, return value, and actually, since this will resize it, we'll just create it with 0 length first, which actually works. All right. Otherwise, we can check. So if So that's basically what it is. This should give us an error already. So let's just do this. So either it does nothing or it gives an error back. Wait, do we have a string equal? Okay, we will need that later, so I guess I'll just write that code in there now. If string equal. So HyperCard comes with a few commands. The nice thing about string equal is it didn't copy. Yeah. And of course that wants... So the nice thing is that this will actually case insensitively compare, as far as I remember. So that's why I'm using this. And so what we need now is we need to get the first argument as a Pascal string. So operation. And now we say we need text utils. Again, I've written this code before, so I've had all the fun finding where which function is and which function exists at all. Basically what I did is I went into inside Mac and, oh, there is a volume named text. And so I searched around in this documentation file a little bit and eventually ended up at num2 and found, okay, there is a num2 string. Wait, no, it wasn't that. It was, I searched for Pascal. And so also has an equal string command, identical string, and lots of other stuff, but anyway, somewhere here is a is it 2 Pascal? Okay, I don't remember. Anyway, I searched around there. It took me quite a while to find all this stuff. In the end, I found them. And I can now have a short peek here and see what the 0 to pass, that was it. Even worse. So yeah, that's what we're doing. We're taking a 0 terminated string, which is the params 0. We need to dereference this once because it is a handle, and handle means it's a pointer to a pointer. And we copy that into operation as a Pascal string. Okay, so now we have operation, and now we can say, okay, operation, and a Pascal string, again, \p, and we say install, for example. So if string equal so that would, you know, do the install operation, and we can do the same for all the other commands that we intend to implement. So that means so install, remove, and fill rect. All right. So we'd have these commands for later. They're not doing anything right now, but hey, we're getting there. Alright, and now build it again. Oh, it doesn't have strlen yet, which I think is in string.h. What was the other thing that was missing? Oh yeah, I named the block something else. Alright. Okay, we got a build, and so now we will run our hypercolor stack. Oh, there's some leftover code in there that we don't really need. Okay. Oops, my mouse just went a little jittery. So now if we test it, it says it gave us expected operation name, install, remove, fill rect as first argument. Okay. And now we'll change it to, so we ended up in this case here. And now we say install. And now we don't get the error message again. So we're ending up in the later cases. So yay. So now how does this work? How do you get HyperCard to tell you when you need to draw color? Well, that's a very clever trick that they play there. Which is that you provide functions to QuickDraw. QuickDraw has a set of functions, the QD procs, that you can replace. So what we will do is we declare a global variable here, which is our procedures. And so now when install is called, we will create some memory size of QD procs. So this gives us memory. And this is basically standard stuff that someone who has worked with QuickDraw would know how to do. Usually what this was for printing. So these are main bottleneck functions that get called whenever you run a drawing program. So when you say fill rect, it would actually go into the QD procs of your current drawing context, of your graphics port as it's called. And would then call a function there that draws the rectangle. And usually it would draw it into the pixel buffer on screen, but when you're printing, it would replace all these functions with functions that, you know, use a higher resolution and generate, I don't know, PostScript or whatever, and just send it off to the printer at the end. And so that way you could use the same drawing code to draw to the screen and to the printer, which was a novelty at the time, and is basically how everyone does it these days, if they support printing still. And now we'll call set standard procs on these QD procs that we allocated. So set standard procs just assigns the standard functions to that. And then we will get a graphics pointer, which is a graphics port. So the thing into which we're drawing. We do this with get port. This doesn't create a new port. It just gives us the current one. And wait, I think the way it works is it works like this. So yeah. So we've initialized this proc structure with the standard functions. And now, right, what we also want to do is bits. I think it's called bits proc. We will see when the compiler complains. Okay, yeah, we don't have, and there we will say colorizing bits proc. So the standard function is called standard bits. So std bits like here. And so here you see the QD procs actually. And here you have a bits proc. That is what it's called. And so now we need to okay, here is the standard bits function, and we will define our own function that is basically the same. Pascal void. And so what that does is it takes this bitmap, this black and white bunch of pixels, and draws it into the current port, or rather this portion of it into this portion of the current port. So we call this colorizing bits proc. And oops. All right, typing is hard, especially when you're used to like macOS 10 like shortcuts, and then here it's macOS 9. All right, and now to get the regular drawing through, we'll just say we'll just pass on pretty much everything. Source rect, teststack, mode, and mask region. Though one thing we want to do, well, no, let's do that first. And so now, one thing we need to do here though is bits proc. Where was it? QD bits UPP. So the thing is here, new QD bits proc. So again, since we might be a native, so like the rule in for interoperability is that if you use a function pointer and pass it to a system API, you have to do it via this new QD bits proc, which will do the right thing on 68,000 or PowerPC. Basically it will add a little marker before the actual function pointer, so that if 68,000 code tries to call it, it will jump out of emulation. And if PowerPC code tries to call it, it will actually, if it doesn't have this marker, it will start the emulator and run it as 68,000 code, because it doesn't know that whether our external is necessarily PowerPC at this point where it just calls this function. So basically they just said all these function pointers are default assumed to be 68,000 or PowerPC that is marked. So it's just compatibility stuff. It's not really important. It's just what you have to do here. So let's see. Oh yeah, we don't have a prototype for this function. We should probably add that. All right. Okay, and the stack is open, so it can't actually... Yeah, now it can actually write out the product. So that part actually works. Now here's one thing. We want to draw color over it somehow. So how do you do this? Well, first we need a color. Let's just pick a very simple color, something like red. All red in RGB, so not a beautiful red, but hey, what can we do? We also need to remember the old color, because otherwise copy bits will tint everything in the foreground color. So get for color is the command for that. And that remembers our foreground color. And then at the end, all right, so we're remembering the color and restoring it. And now, of course, we set the color to red. And let's just do a fill rect. No, it's called paint rect. And the rectangle we'll be using for now is 10, 10, 110, 210. So here's the thing, rectangles in QuickDraw, in the drawing API of classic Mac OS, are actually stored as vertical first, then horizontal. So down, right. So it's top, left, bottom, right. And so this should give us a sideways rectangle. Oh, wait, it's not set RGB for color, it's just RGB for color. Right, yeah. All right. And so we just install this handler. And to remove it, what we do is we need the current port, and then set the current port. Oh, I think we forgot to actually set it on the port. Yeah. Current port graph prox. Okay, GQD prox. And so we set this to null and then clean up the memory we allocated for that, and just so we're tidy, we will actually set it to null again. And so what we could do is here, before calling install, we could check that it's actually null and that install hasn't been called twice. And here on remove, we could actually check that it's not null and only remove it then. All right. Oh, and of course we need to typecast again. All right, but that should be fine now. Good. All right. Oh, yeah, that's already set to use install. And now I forced to redraw, and you see it actually draws our rectangle. And if we do anything in HyperCard, you see it ends up behind our color. So we have the desired effect. The thing that we need to do this is if we just ran this code here, you know, get the color, paint a rectangle, and then restore the old color, HyperCard wouldn't know that there is a red rectangle here. And so as soon as I click the button or something, if something in this area redraws, like if I click the title or something like that, it would actually erase part of this and paint the background over it again. And so by registering here for these standard procs, we actually get our color to be persistent on top of that. Now, of course, what we really want to do is we want to replace the white stuff with the color. So how do we do that? What you would have to do in this case is you would have to do this afterwards, the calling through to the original copy bits, and use a different mode. So if we go into quickdraw.h, there are different pen modes here. It's copy, or, XOR, and all sorts of copying modes. For example, I'm not sure if I think source or is what we want. Copy is usually the default, so we would say mode source or. Oh, okay, yeah, we have to quit HyperCard again, build it, run it. Yeah, and now you see, so what it did is the red shines through. So that's basically what add color does, and is basically all. Add color does a little more. Add color, of course, doesn't just have a hard-coded rectangle in one position. It actually adds resources to your stack with the color information. So if we have a peek at this in ResEdit, you actually see that there is an HCCD, and there's also a corresponding HCBG resource for card or background. So that is the two layers of a card in HyperCard. And in this resource, it actually has a list, like it says here. Yeah, I can't really decode this hex format by memory, but here on HyperCard.org you can actually find a file that describes the format of these resources. Basically it's just a list of all the buttons and what colors you have set for them. Or in other cases it's you know, a list of, like, you can also like just put a colored rectangle or a colored picture somewhere, like a picture file or a picked resource, like we saw them inside HyperCard, for example, for the about screen. Yeah, and that's basically what you need to imitate the colors that HyperCard has on your own. And you could do some really fancy stuff that way. So I hope that has been helpful in some way for you. If it hasn't been helpful as, you know, like an explanation of internals of HyperCard, at least it would have been helpful as a quick run through of how you create an external command and a little reminder of the details you have to do with the code. So one small warning here, that I'm keeping these procs in a global variable. I mentioned that before. This thing is locked, and I've made it not purgeable. I'm not 100% sure this is correct. If you look in our color test stack, what add color does, here it actually has these bits and check. And so if you see copy bits, that's the name of the function that that HyperCard uses to call the bits proc. So copy bits is the command that ends up calling the bits proc in the end. And so they have a code resource here containing the code. So compile that as a separate resource. And my guess is they do that because then they can just load that into RAM and it's guaranteed to not go away even if the external gets unloaded. And another trick is you can store stuff in a code resource and can, use some assembler or something to, like if you have a global variable that will end up compiled at the start of your function, then you can just take the pointer to this resource and write some information into the start of that function. Which, from today's point of view seems crazy because you usually don't want to mix code and data, because then if you overrun the data, you change the code, and that's how hackers get into your systems. But back then, that was a fairly normal thing to do, or at least wasn't considered, like super dangerous yet. And so my guess is that that's what they do, and my guess is that this timestamp, this check thing here, is used because since you're modifying this resource, if you quit the stack and forget to remove, add color, forget to remove these QD procs, then it might, on the next startup, use the invalid pointer that has been written into this resource when you terminate your program. And so that's my guess, that they use this to kind of check when was HyperCard last started, and if that has been long ago, then they know this can't be correct, and they will overwrite these values with new ones and just assume you have been quit in the meantime. Anyway, that's basically it. I know it's been a long talk, but I hope it was fun as an exploration of programming on a decades-old computer system, or operating system at least. The computer system is actually fairly new because it's running an emulation, and learning something about the internals of an old and legendary piece of software. Thank you for listening, and have fun.